Welcome back. Today we are going to be talking about lesson 11.7, which is about measures of center and measures of variation. So we are going to start with measures of center, which we call. So in this lesson, we're going to go through three main measures of central tendency. The first one is going to be the mean, which we call the statistical average in math. And you can see the formula there. We use the symbol X bar to mean the mean, to represent the mean. And so the formula is there. Basically, it's saying we add or sum all of the different data pieces that we have, and then we divide by n, which is the number of pieces of data we have. So if we look at the example over here, on the right, we have these 6 numbers. To find that mean, we are going to add them all up. So I'm going to take each data value, add it together using a calculator. And then I'm going to divide by the total number of pieces of data there. So in this case, that is 6. When I add those up and divide by 6, I get a mean X bar of about 85.2. So that's how we calculate the mean, or the statistical average that's going on there. The next measure of central tendency that we're going to talk about is the median. And the median is the middle value when the values are placed in order. So it's really important that we put things in order first. Okay, so in this statistical data set that we were looking at as our example, the middle, these are in order from lowest to highest, the middle is in between 83 and 89. So when that happens, when there's an even number in our data set, the middle is going to fall in between two numbers. So we find the average of those two numbers by adding them up and dividing by 2. And that is going to give me the median. In this case, the middle of 83 and 89 would be 86. So the median is the middle number. And then lastly, we have the mode, which is the data value that occurs most frequently. So when we look at our data set here, we're looking for ones that repeat or occur more often than the others. In this case, they all appear once. So we would say there is none. There is no mode in this case. Sometimes we have one number that appears more than the rest. Sometimes we can have more than one mode as well. All right, so now we're going to look at some ways to display the data that we have been talking about. So we're going to start with a stem and leaf plot. So a stem and leaf plot is just a useful way to organize our data and display it in a way that's a little different than just a straight list. So when we do a stem and leaf plot, let's look at an example down here. So when we have a stem and leaf plot, the stems are on the left side, and those represent some of the beginning numbers in that data set. So the leftmost digits, the one on the sides, are called the stems. And then when we list out the numbers in order on the right side, those are your leaves. So we use that vertical line segment that you can see in that example to divide the stems from the leaves. The stems always go from lowest to highest on the left side of the line. And then the leaves also go from lowest to highest on the right side. So let's look at an example of these over here. Okay, so we have our data values there. And when we make our stem and leaf plot, we're listing them again. So the 5 represents all the 50s. So in this case, we just have a 54. So I would just write a 4 next to that 5 to represent 54. For the 6 or the 60s, we have a 68, we have a 62, and we have a 65. Remember that when we write these leaves, we want to write them in order from lowest to highest. So we have 62, 65, and 68. We leave a little space in between each number, so it's not like we're writing them next to each other to represent that they're different numbers that are going on there. So we're going to continue on. There are no 70s, so I'm not going to put anything there. For the 80s, we have an 80, an 81, and an 87. And again, we're organizing the data, so we want to keep things lined up so it's easy to see which group has the most and that kind of stuff. 90s, we have two 93s. So I'm going to write 2 3s next to each other. You do need to represent each individual data point with its own value. And then we get to 10, which represents the hundreds, and we have a 102. So I would just write the 2 part. All right, so now that we have them in order, we are going to go through and find the measures of center. So for our mean, we're going to add them all up. 54, 62, 65, 68. Then we have our 80, 81, and 87. And then we have 293s and a 102. We're going to divide all of that by the total number of pieces of data there. So if we count them up, we can see that there are 10 data pieces. When I do that, and I divide by 10, I get a mean of 78 and a half. Remember, the median is that middle number. So I just figured out that there are 10 data pieces. So the middle is going to be in between that fifth and sixth term. That's where my middle's going to lie. So our fifth and sixth term are 80 and 81. So I'm going to find the middle of those. You can add them up, divide by 2. Some people also can figure it out in their head. In the middle of 80 and 81 is going to be 80 and a half. And then finally we have the mode. So we're looking for something that's repeating more than the other ones. And in this case, I have a 93 that occurs twice, while the rest only occur once. So now we're going to use that same idea, but we're going to work backwards a little bit. So now what we're going to do is we are going to find a value once we know the mean. So one of the most common ways to think about this is if I have some tests that I've taken in a class, and then we're going to average them all together, and I want a certain test average, then I got to figure out what I got to get on that last test to get that test average. So in this case, so far we have scored a 90, an 82, an 89, and a 93. And now I'm going to take my last or my fifth test. So together, those are my 5 data pieces. What I want that to give me an average of is a total score, an average score of 90. So to average these, I'm going to add them all up and divide by how many there are. So we know we're taking 5 tests total. Even though we don't know that last score, we're still dividing by the total amount that we want. And we want that average or that mean to be 90. So that's what my equation would look like. Once we have that set up, we're just going to simplify and solve from there. So if I add up the 4 pieces of data that I do know, I get a total of 354. So far, I have 354 points on my 4 tests that I've taken, and I want to figure out what I have to get to that 90. So we've got that set up now. Now we're just going to solve. So I'm going to multiply both sides by 5 to get rid of that denominator. That's going to give me 354 plus x, and then equals 90 times 5, which is 450. So what that's saying is that I need 450 total points over the 5 tests to maintain an average of 90. Right now I've got 354. So if I subtract the 354 from both sides, that tells me that my last or my 5th test value needs to be a 96% in order to maintain that 90% average. Okay, we're going to move on to the next part. So we've been talking about measures of center. Now we're going to talk about measures of variation. So variation measures spread, or how spread out, or the distribution of a data set. So let's go through a few more vocab pieces here. One that you're probably familiar with is the range. The range is the difference between the greatest value and the least value. So we say that's the maximum and the minimum. So the difference between them, difference in math, of course, meaning that we're going to subtract them. So that's the most basic variation measure. Then we have something called the variance. The variance is the average of the squared differences from the mean. So we have a formula for that we're going to write in here. And that formula, we use the Greek letter sigma. So we say sigma squared because it's the average of the squared differences. So we call it sigma squared. And to find it, we do the sum from 1 to however many total pieces we have of all the differences from the mean. So taking each data point and subtracting it from that mean, which we use the Greek letter mu for, and we square it. And then since it's the average of them, we divide by how many pieces of data we have. So that's variance. All right, a couple other pieces of information for variation. We also have variation that's called deviation, which is where each difference, where we find each difference. So that difference between a data point, which we call xi, minus that mean we've found. That's called a deviation. Deviation means how far away from typical it is. So we're finding the difference between a data point and the mean. So when we look at the numerator of that variance formula we just wrote, it's the sum of the squares of all those deviations. So deviation is part of the variance formula. All right, and then lastly, we have standard deviation, which is how much a typical value in the data set differs from the mean. So to find that, we take the square root of the variance. So standard deviation tells us on average how far away is each data point from the mean. So to find that, we do the square root of the variance. Within those standard deviations, if we have a lower standard deviation, that means that the values are really grouped close together. They're not very far away from the mean. And if we have a higher standard deviation, that indicates that the values are more spread out from the mean. They're further away on average from the mean. Okay, so we're going to go through some examples of how to find these things. So these things involve a lot of calculating. So for example 3, we're going to compute the variance and the standard deviation of this data set. All right, so we're going to find some things that are going to help us in the calculation of the standard deviation and the variance. So the first thing is the range. Remember, the range is the maximum minus the minimum. Remember the difference between the two. So when I look at my data set, my highest piece of data is 32, and my lowest piece of data is 6. So when I subtract those, I get a range of 26. All right, now in order to calculate our standard deviation and our variance, we're going to have to find the mean of all this. So remember, the mean is adding them all up and dividing by how many there are. So we're going to add them all up using a calculator if you need. And divide by how many there are. So when I do that, I have 8 total pieces. So when I divide that out, x bar, remember that's the mean, comes out to be 20. So our average piece of data is 20. All right, so in order to calculate my variance now, I need to use this table over on the right to kind of help me with that. So in the leftmost column is just the list of data values. So what we're going to do to start is we're going to take each data value and subtract out that mean. So for this first one, we're taking the data value, subtracting out the mean. That would give me a value of negative 10. 18 minus 20, that's a value of negative 2. And we just keep subtracting 20 from each one. So this one would be negative 14. 27 minus 20 would be 7. 23 minus 20 would be 3. 14 minus 20 would be negative 6. 30 minus 20 would be 10. And 32 minus 20 would be 12. So first we find just that general distance each point is from the mean. Then we're simply going to square each of those numbers. So taking each of those that I just wrote in the middle column and squaring it. So negative 10 times negative 10 is 100. Negative 2 squared is 4. Negative 14 squared is 196. This one would be 49. And we keep squaring all the way down to the bottom. Then remember, the variance formula is the sum of those divided by how many there are total. So in this case, when I add up that column, I get a sum or a total of 638. That's what we're going to use in order to calculate the variance. So remember, variance is sigma squared. and we take the sum of those differences squared, so 638 that you just calculated it, and you divide it by the number of pieces of data we have. In this case, that comes out to 79.75. So our variance is 79.75. From there, it's very easy to calculate the standard deviation. If you remember from before, standard deviation is just the square root of the variance. And when we take the square root of that 638 over 8, we get a value of about 8.93 if we correct. All right, so like I said, these measures of variation sometimes take a little more calculating, but that is the process that you're going to go through. We'll see you next time.